Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 9th grade topic, imaginary numbers. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we said today, or even on homework, you can always put it in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I've been linking my 9th grade playlist in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 3 parts, so leave a like, smash subscribe, and let's get started. What are imaginary numbers? Well, if you think about all the numbers that you've come in contact with at this point, from when you first started learning about counting way back when, those would probably fall under one umbrella called real numbers. Real numbers. Those are going to be your integers, your natural numbers, your whole numbers, your rational numbers, your fractions, your decimals, your irrational numbers. All of those numbers that you have used over the years would fall into this category called real numbers. However, we have this other category called imaginary numbers that we haven't really talked about. Now, what would be in the imaginary numbers camp if everything that we've talked about so far has been a real number? Why do we even have imaginary numbers if everything that we're going to use would fit into this one camp? Well, imaginary numbers came about because it was something that real numbers couldn't do, and that's solve something like this: the square root of negative 25. Using everything we know about real numbers, we can't get an answer to this. However, that's where imaginary numbers comes through. Your basic definition of an imaginary number can be written as follows: either I equals the square root of negative 1, or you can say I squared equals negative 1. Now you may be looking at both of these and saying they're pretty much the same thing. If you square this, you'll get this, and you would be correct. However, this first definition here, this has a contradictory element that some people like to point out. That's not really contradictory, but if you're doing something, it may look contradictory. But we'll talk more about that later on in this video. But either one of these are fair game. I don't want to scare you off. You can use either one of these. They're both true, but just know that some people may find this definition lacking. But using what we know here, we can now solve something like this where we couldn't if we were just using real numbers. This can now be broken up into your square root of negative 1 times your square root of 25. And we know that the square root of 25 is going to be 5. And we just said that the square root of negative 1 is going to be I. So this is going to be 5i. And that's how imaginary numbers helps us with the square root of negative numbers. But now that we talked about a little bit of the background for imaginary numbers, let's move on to a really cool property of imaginary numbers. Now, one cool property for your imaginary numbers, that basic I, is that whenever you raise it to higher and higher and higher powers, it does something rather unexpected. Now, if you was to raise 1 to some number, right, let's say squared, and you found what that was, you would see it's just 1. And if you were to do this for higher and higher and higher powers, you would see that 1 is going to stay the same for any power of 1. 0 has something else like that as well because it doesn't change. However, everything else is going to either get much larger or much smaller. So it either stays the same, grows, or shrinks. But that doesn't happen for your basic i's. They're going to do something called cycling. That means they're neither going to grow nor shrink. They're just going to keep going in a circle. And you see what I mean by that. Let's start with our basic I, raise it to the 0 power. So I to the 0 power, anything to the 0 power is going to be 1 here. So we start there. Then we're going to do I to the first power, which is going to be I. Then you have I to the second power. That's just going to be what we said, that I squared is going to be negative 1, right? We also said that I was going to be the square root of negative 1 here. So we could have both of those definitions up here, but we know from this definition that I squared is going to be negative 1. I cubed is going to be what? Well, we can break that down into I squared times I. We know what I squared is. Negative 1 times I. So we know that this is going to be negative I. Then we have I to the fourth. Well, I to the fourth can be broken down into I cubed times I. We know that I cubed was this negative I times I. And you know that multiplication, you can move things around. So technically I can have negative 1 times I times I. What's I times I? Well, that's going to be I squared. And I squared is going to be what? Negative 1. So we have a negative 1 times negative 1. And what's negative 1 times negative 1? 1. So if we look at this, we start off with I raised to the 0 power equaling 1. And we got all the way to I raised to the 4th power equals 1 again. We didn't grow or shrink. We simply cycled and we're going back to 1. But let's see if this pattern continues as we get higher than 4. And I'm going to collapse this to give us a little bit more space here. Let's say we had I to the 5th power. Now this can just be written as I to the 4th times I, and we know what I to the 4th is. That's going to be 1 times I, and that's just going to be an I here. So actually I'm going to write that right here so we can have it once again next to the place that is going to be repeating. So I to the 5th power is going to be I. How about I to the 6th power? That's going to be I to the 4th times I squared. We know what I to the 4th is, 1, and we know what I squared is, times negative 1. So what is this going to be? Negative 1. I to the 7th power is going to be I to the 4th times I cubed. We know that I to the 4th is going to be 1. I cubed is going to be negative I. That means this is going to be negative I. And I to the 8th is going to be I to the 4th times I to the 4th. And both of these are going to be 1, which gives you 1. Notice that I to the 5th goes back to I, right? We cycled back to 1 and we're starting it all over. I squared, same as I to the 6th, negative 1. I cubed, same as I to the 7th, negative I. I to the 4th is the same as I to the 8th, 1. And notice how we did that. For our higher powers than 4, we broke it up into a power of 4 times whatever is left over. And that's because I to the 4th is always going to be 1. And on top of that, we realize that any multiple of 4 that you're going to raise I to is going to be 1 as well. So if we want to tackle even higher powers of I, we can easily do that using this property. Let's say we had I to the 101st power. Well, you can break that up into I to the 100th power times I, and I to the 100th power is just going to be I to the 4 times 25 times I. And of course, you can write that I to the 4 to the 25 like this, times I. And I to the 4th power is going to be 1. 1 to any power is going to be 1. So that's just going to be I here. So this is just going to equal I, because this goes away and it just equals 1. So it doesn't matter how big your exponent is, if you can find your multiple of 4, break it out, and whatever is left is going to be what remains. But now that we talked about this cycling property, let's move on to that seemingly contradictory element of this definition here. I equals the square root of negative 1. Now I say this is seemingly contradictory once again because if you do what I'm about to do, at first glance, it looks like you have a contradiction. So follow along and see if you can figure out what's wrong with what I'm about to show you. So let's start with negative 1. Negative 1 is going to equal what? Now we know that I squared equals negative 1. That's our other definition. So this is going to be an I squared. We can write that as I times I. Now we said that I equals the square root of negative 1, and you can then substitute this to be square root of negative 1 times the square root of negative 1. Now we know that we typically have stuff like this in which we have two radicals multiplied, the same powers, right? So we can combine them, and you're going to have negative 1 times negative 1. And you can simplify this under the radical, and you're going to have the square root of 1, right? And the square root of 1 is going to be what? 1. So that means that -1 actually equals 1. Hence our seemingly contradictory statement. If I is going to equal this square root of -1, we're going to get this contradiction here. But that's actually not true. Although this looks correct, it uses something that's not true in order to make this look like it's correct. And if you haven't spotted what's wrong, it's this right here. Now we do this all the time. If you have A times B, you can break that up to A and B like this. This is something that we know and love. We do this all the time. But typically your A and B are both positive. So you didn't really have to focus on this aspect of this property. But in order for this to be true, A, B, either one of them has to be greater than or equal to 0. Not both. If you have at least one that's greater than or equal to 0, this is true. But when you have them both negative, if they're both less than 0, this is not true. You're always going to get something completely messed up. So you can only use this property if at least one of these is greater than or equal to 0. That's not the case here. Both of these are less than 0, so therefore you can't use this property. So this contradiction doesn't actually happen because you were never supposed to use this property to begin with. So I only showed this because there was a seemingly contradictory element, and I didn't want you to fall into that trap if you were to try to do something like this and wonder why your -1 all of a sudden equals 1. Or better yet, if someone tells you that this is not true because it's contradictory, you know that there was something that they probably did wrong in their math that made it seem like so. But both of these definitions are going to be good for you to use. You can use I equals the square root of -1, or you can use I squared equals -1. It doesn't really matter. Neither one of them are actually in fact contradictory. It's just that it appears that way because of a misuse of a certain property. So I hope you were able to follow along with today's video, and I hope you now know a little bit more about your imaginary numbers. However, if you have any questions about what we said today or even on homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I really hope to help with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Sempai.